Let's see the answer of IGCSE Edexcel Physics Paper 1 PR May 2025. Starting from the question 1. The diagram shows a truck traveling along a horizontal road. Total resistive force is 16 kN and driving force is 16 kN. So the diagram shows the horizontal forces acting on the truck. Give the resultant horizontal force acting on the truck. So the resultant force equal to 16 minus 16, which is equal to 0 kilonewton. So the answer is 0. Then question BI. The driver of the truck has to stop because a tree has fallen on the road. The thinking distance of the driver is 7 meters and the braking distance of the truck is 20 meters. Calculate the stopping distance. So the stopping distance equal to the thinking distance plus braking distance. So it is equal to 27 meters. Question BII. Give two factors that would affect the braking distance of the truck. First one is the mass or weight of the truck. And another one is the condition of tires. Then question BIII. Which of these factors would decrease the driver's thinking distance? So this option D. The truck is traveling at a lower speed. Question 2. This question is about magnetic fields. Diagram 1 shows the poles of the two strong bar magnets being held close together. There is a uniform magnetic field between the poles of the bar magnet. Complete the diagram 1 by drawing magnetic field lines to show the uniform magnetic field. So it will be like okay. So I should label the pole of the bar magnet, right? So this one is north and this one is south pole. Okay. Then question B. Diagram 2 shows a strong magnet attracting an iron block. The iron block becomes magnetized when it is in the magnetic field of the strong magnet. Label the magnetic poles on the magnetized iron block in diagram 2. So this one will be a north pole and this one will be a south pole. Then question II. A student takes the strong magnet away from the iron block. The student suggests they can permanently use the iron block to attract small pieces of iron. Explain whether the student's suggestion is correct. So it will not work because iron will lose its magnetism and because iron is a magnetically soft material. Question 4. A student does an experiment to investigate energy transfer by conduction. A. The student plans to use the piece of apparatus shown in the photograph. The apparatus has 4 bars made from different metals. When the apparatus is placed in hot water, energy is transferred from the bottom of the bar to the top of the bar. The temperature-sensitive strip on each bar changes color as the temperature of the bar changes. The time taken for the color change to reach the top of the bar can be used to compare how effective each metal is at transferring energy by conduction. I give 3 control variables in the student's investigation. Okay, first one is the same length. All bars with the same length. Two, all bars with the same width. And 3, all bars with the same thickness. The student has this equipment: beaker, hot water, stop clock, clamp, and clamp stand. Design a method the student could use to compare the effectiveness of the metals at transferring energy by conduction. You may draw a diagram to help your answer. So the first one is support apparatus in clamp stand. Next, place apparatus into hot water and start stop clock. The third is determine time. Determine time for color change. To reach top of the strip. Fourth, allow apparatus to cool. And the last one is repeat and calculate mean for each bar. Question B. The table shows the result of the student investigation. Plot the bar chart of the student's result. Okay. Then from 22 to 115. Okay, so we have 29 aluminum, then 64 blast. Then 22 copper. And the last 115 steel. Okay, then question II. Deduce which method is the most effective at transferring energy by conduction. So, copper is the most effective. Because the time taken is shortest. Question 5. The photograph shows a cloud chamber used to observe alpha radiation produced by a radioactive source. The radioactive source is inside the cloud chamber as shown in the photograph. Describe the structure of an alpha particle. Okay, so it is a particle that contain protons and neutron. It consists of two protons and two neutrons. Question B. The source used in the cloud chamber contained the isotope of radium-226. The incomplete nuclear equation shows the decay of radium-226 into an isotope of radon. Okay. Complete the nuclear equation by writing the correct numbers in the boxes. So it will be 2 and 4 here for the alpha radiation. So this one will be 222 because 222 plus 4 equal to 226. Okay. Then question C. The tracks in the cloud chamber can be seen through the glass viewing window. Explain why the radioactive source is not hazard to the person viewing the cloud chamber. Okay. First one is alpha source is outside body. And another one is alpha has poor penetrating ability. Question D. When radiation is emitted from the source, a white line is produced in the cloud chamber. The white line is known as a track. The diagram shows the track produced by the radiation from the source. The diameter of the cloud chamber is also shown. Explain the properties of alpha radiation that can be deduced from the length of the track. Okay, first, all tracks are approximately same length. Then so all alpha particles have the same energy, and alpha radiation is short range because the tracks are short. Question 6. The photograph shows a rocket being launched at Cape Canaveral in the United States of America. The table gives some information about the motion of the rocket during the first 5 seconds of its launch. So we have the initial velocity at 0 meter per second, acceleration equal to 13 meter per second square, and time taken equal to 5 seconds. So calculate the final velocity of the rocket after 5 seconds. Assume that the acceleration remains constant during this time. So the formula is A equal to final velocity minus initial velocity divided by time. So we have acceleration equal to 13 equal to final velocity minus initial velocity, which is 0, divided by 5. So final velocity equal to 13 times 5, which is equal to 65 meter per second. Question B. Calculate the distance the rocket traveled during the 5 seconds. Assume that the accelerations remain constant during this time. So we have v squared equal to u squared plus 2as. So final velocity is 65 squared equal to 0 squared plus 2 times 13 times s. (65 squared) equal to 4,225 equal to 26 times s. So therefore, distance equal to 2,225 divided by 26, which is equal to 162.5 meters. Then question C. Sketch a velocity time graph and a distance time graph showing how the motion of the rocket changes during the first 5 seconds of its launch. You do not need to include values on the axis. So the velocity time graph will be like this. And for the distance time graph, it will be like this. Question 7. This question is about light. Light is an example of a transverse wave. Describe a transverse wave. You may draw a diagram to help your answer. Okay, so it is a wave in which an object is vibrated perpendicular with the direction of the wave travel. Okay, so it is like this. That's it. Then question B, diagram 1 shows a ray of light in a section of optic fiber. So the ray of light is incident at the boundary between the optical fiber and air. The ray of light reflects at the boundary. Complete diagram 1 by drawing reflected ray of light. So it will be like this. So we will have angle of reflection and angle of incidence. Okay. Then question II. Explain why no light leaves the optical fiber when the light reflects at the boundary between the optical fiber and air. Okay. Because the refractive index of air is less than refractive index of optical fiber, then the angle of incidence is greater than critical angle. Therefore, it will be the total internal reflection. Okay. Then question C. Diagram 2 shows a different ray of light incident on the boundary between water and air. Using diagram 2 show that the refractive index of water is approximately 1.3. So this angle, which is the critical angle, equal to 50 degrees. Okay. So we have sine of critical angle equal to 1 over n. So we have sine of 50 degrees equal to 1 over n. So therefore, n equal to 1 over sine 50 degrees, which is equal to 1.305. Question 8. This is a question about the solar system. Give the name of the galaxy the solar system is in. So the answer will be Milky Way. Question BI. Neptune is a planet in the solar system. Triton is a moon that orbits the planet Neptune. Draw a diagram to show the orbit of Neptune and the orbit of Triton in the solar system. Okay, So we have a sun. Let's say this is our sun. Okay, so therefore Neptune orbits the sun. Yes, so this is Neptune. Okay, and Triton orbits Neptune like this. Okay, then question BII. Neptune orbits in the solar system and at an orbital speed of 5.4 times 10 to the power of 3 meter per sec. With an orbital radius of 4.5 times 10 to the power of 12. Pluto is another object in the solar system. Pluto orbits with the time period of 7.8 times 10 to the power of 9 seconds. Show that the ratio of the orbital time period of Neptune to the orbital time period of Pluto is 2 to 3. So we have the orbital speed equal to 2 pi r divided by time period. So the orbital speed is 5.4 times 10 to the power of 3 equal to 2 times 3.14 times radius, which is 4.5 times 10 to the power of 12 divided by time period. So therefore the time period equal to 2 times 3.14 times 4.5 times 10 to the power of 12 divided by 5.4 times 10 to the power of 3. So the time period equal to 5.2 times 10 to the power of 9 second. Okay, now we will find the ratio. Ratio equal to 5.2 times 10 to the power of 9 to 7.8 times 10 to the power of 9. So 10 to the power of 9 can be cancelled out. Okay. And then I will divide by 2.6. So the ratio is 2 to 3. Question 9. A. The diagrams show a spring hanging from a nail. Diagram 1 shows a spring with no weight added. Diagram 2 shows the spring stationary after weight has been added. And diagram 3 shows the spring after the weight has been pulled down. So I. Which energy store has increased for the spring in diagram 2 compared to the spring in diagram 1? So it will be elastic energy. Then question II. The spring is released from the position shown in diagram 3. Describe the energy transfer that takes place until the spring stops vibrating. So the first one is elastic energy store. Decreases. And then kinetic energy store. Increases. And gravitational store. Increases. And then energy transfer mechanically. Next is that the amplitude of oscillations decreasing over time. And the last point is that all energy is transferred to thermal store of spring. Then question B. Shock absorbers contain springs are used on motorcycles. Shock absorbers are designed to compress and expand as the motorcycle moves across a rough surface. A new type of shock absorbers has been developed to generate electricity from the movement of the motorcycle. This new type of shock absorbers consists of magnets that slide inside a coil when the motorcycle goes over a bump. So some of the energy that would normally be wasted can be recovered. So fuel is safe. Question I. Which of these statements best describes the advantage of this new type of the shock absorbers? Okay, so it will be B. It increases the efficiency of the motorcycle. Then question II. Explain how this new type of shock absorbers can generate electricity. So the first one is magnet move through coil. And then coil cutting magnetic field lines. And the last point is that inducing of voltage. Then question III. Road X has a rough surface. Road Y has a smooth surface. A motorcycle travels at the same speed along road X and road Y. Explain why the new type of shock absorber will generate more electricity for this motorcycle on road X than on road Y. So the first one is road X will have more bumps than magnet have bigger amplitude of motion and so induced voltage generated is larger. Question 10. The photograph shows a ring made of gold. A student wants to determine the volume of the ring. A. The student measures the mass of the ring several times. I. Describe how the student should use laboratory equipment to accurately measure the mass of the ring. So the first one is use of a balance. And balance should be 0. Okay. Then II. The table shows the students' measurements of the mass of the ring. One of the students' measurement is an anomaly. Draw a circle around the anomalous result in the table. So it will be this one. Then calculate the mean mass of the ring. So it is equal to 6.411 plus 6.408 plus 6.41 plus 6.412 divided by 4. So the mean mass of the ring equal to 6.410 gram. Then question IV. The student is given a value for the density of gold. Which of these formulas should be used to calculate the volume of the gold ring? So since density equal to mass over volume, so therefore volume equal to mass over density. So it will be option C. Then question B. The student does not know if the ring is made of pure gold. The student suggests that they could also measure the volume of the ring using a displacement method. Discuss which method, calculation method or displacement method, will give the most accurate volume measurement. Okay, so the first one is that density will depend on purity of gold. Okay, so calculating volume will be affected by purity. Okay, and then I think mass measurement being 4 significant figures, okay, and one more thing is small volume of ring will be difficult to measure using the displacement method. Okay. Question 11. A ball is moving through the air with a speed of 54.8 meters per second. The ball has a mass of 159 grams. Calculate the energy in the kinetic store of the ball. Give your answer to 3 significant figures. So we have kinetic energy equal to 0.5 times mv squared. So we will have 0.5 times 159 times 10 into the power of negative 3 because we have to convert from gram into kilogram. Okay, and then times v square, which is 54.8 square. So the kinetic energy equal to 239 joules. Then question B. The speed of the ball is measured using radio wave. Radio wave of frequency 2.9 times 10 to the power of 10 Hz travel towards the ball from a source. The radio waves then reflect off the ball. The reflected radio wave change frequency depending on the speed of the ball. This change in frequency due to the Doppler effect. So question I. The change in frequency can be calculated using this formula. Speed of the ball equal to change of frequency over source frequency times speed of radio wave divided by Q. So show that the change in frequency of the radio wave is approximately 1.1 times 10 to the power of 4 Hz, given that the speed of the radio wave is 3 times 10 to the power of 8 meter per second. Okay, so we have 54.8 equal to delta F divided by 2.9 times 10 to the power of 10. Okay, and then times speed of radio wave, which is 3 times 10 to the power of 8 divided by 2. So therefore, if we rearrange the expression, we will find the change in frequency equal to 10.6 times 10 to the power of 3 Hz. And then question II. The change in frequency of the radio wave happens because the ball acts as a new source of radio wave. The ball is moving away from the original source of radio wave. Explain the change in frequency of the radio wave when the radio wave reflects the ball. Okay, so in this case, frequency decreases. And then wavelength increases. And the last one is that speed stays the same.